National Electrical Code (NEC) does not explicitly address the use of non-metallic sheathed cable type B, often referred to as NMB cable, within a shallow chase in masonry block when that chase is subsequently covered with gypsum drywall. However, the NEC does stipulate that NMB cable is prohibited from use in a shallow chase constructed in masonry block if the chase is then covered with plaster, adobe, or any finished material deemed similar in nature. Gypsum drywall shares characteristics with plaster and adobe, notably that it begins as a dry powder that is mixed with water to form a workable compound before being applied to a surface. Given this similarity, it is reasonable to infer that the NEC would likely disallow the installation of NMB cable within a shallow chase in masonry block if gypsum drywall is used as the covering material. It is crucial to understand that the NEC represents a minimum safety standard. Local electrical codes and building regulations may impose more stringent requirements than those outlined in the NEC. Therefore, it is always advisable to consult with the local building inspector or authority having jurisdiction (OJ) in the specific geographic area where the electrical work is being performed to definitively determine whether the use of NMB cable is permissible in a shallow chase within masonry block when the chase is covered with gypsum drywall. The interpretation of similar finish is key. The electrical inspector will use their discretion when making the final decision. There are several factors to consider when determining if gypsum drywall is a similar finish to plaster or adobe. These factors include, firstly, the composition of the materials. Plaster and adobe are typically made from cementitious materials such as lime, sand, and water. Gypsum drywall is made from gypsum, a mineral that is composed of calcium sulfate dihydrate. Secondly, the application method is relevant. Plaster and adobe are typically applied in multiple layers, with each layer being troweled on. Gypsum drywall is typically applied in a single layer, with the seams being taped and mudded. Thirdly, consider the fire resistance. Plaster and adobe are typically more fire resistant than gypsum drywall. If the local building code considers gypsum drywall to be a similar finish to plaster or adobe, then NMB cable would not be allowed in a shallow chase in masonry block covered with gypsum drywall. If the local building code does not consider gypsum drywall to be a similar finish to plaster or adobe, then NMB cable may be allowed in a shallow chase in masonry block covered with gypsum drywall. Ultimately, the decision of whether or not to allow NMB cable in a shallow chase in masonry block covered with gypsum drywall is up to the local building inspector. It is important to consult with your local building inspector before installing NMB cable in this type of application. NMB cable, being a non-metallic sheathed cable, has limitations on its permitted uses. It is designed primarily for interior wiring in dry locations. Direct embedment in masonry or concrete is not allowed. This is due to the potential for moisture and alkalinity to degrade the cable jacket and conductors over time, leading to electrical faults and safety hazards. The NEC specifies installation methods and suitable applications for different wiring methods, including NMB cable, to ensure safe and reliable electrical systems. The purpose of these regulations is to prevent electrical fires, shocks, and other hazards that can result from improper wiring practices. When installing electrical wiring in masonry walls, it is generally recommended to use conduit or other wiring methods that provide physical protection and prevent direct contact with the masonry. Conduit protects the wiring from damage during construction and from moisture and chemical attack over the life of the installation. There are several types of conduit available, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid non-metallic conduit. Each type has its own advantages and disadvantages in terms of cost, ease of installation, and resistance to corrosion and physical damage. The choice of conduit type should be based on the specific application and the environmental conditions at the installation site. In addition to conduit, other wiring methods that may be suitable for use in masonry walls include mineral insulated cable and cable in tray. Mineral insulated cable is a type of cable that consists of copper conductors insulated with a mineral compound, such as magnesium oxide, and enclosed in a copper sheath. This type of cable is highly resistant to heat, moisture, and physical damage, making it suitable for use in harsh environments. Cable in tray is a system that uses cable trays to support and route electrical cables. Cable trays can be made of metal or non-metallic materials and can be installed in a variety of configurations to accommodate different wiring needs. When installing electrical wiring in masonry walls, it is important to follow all applicable codes and standards, including the NEC and any local amendments. These codes and standards provide detailed requirements for wiring methods, conductor sizing, overcurrent protection, and grounding. Following these requirements will help to ensure that the electrical system is safe and reliable. Before starting any electrical work, it is essential to obtain the necessary permits from the local building department. Permits are required for most types of electrical work, including new installations, alterations, and repairs. The permit process typically involves submitting plans and specifications for the proposed work and paying a fee. Once the permit is approved, the electrical work can be performed. After the electrical work is completed, it must be inspected by a qualified electrical inspector. The inspector will verify that the work has been performed in accordance with the applicable codes and standards. If the work passes inspection, the inspector will issue a certificate of compliance. The certificate of compliance is proof that the electrical system is safe and meets all applicable requirements. In addition to following the codes and standards, it is also important to use good workmanship practices when installing electrical wiring. This includes using proper tools and equipment, making neat and secure connections, and protecting the wiring from damage. Good workmanship will help to ensure that the electrical system is reliable and long-lasting. When working with electricity, it is essential to take precautions to prevent electrical shock. Always disconnect the power before working on any electrical circuit. Use insulated tools and wear rubber gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take precautions to protect yourself from harm. In summary, the use of NMB cable in a shallow chase in masonry block covered with gypsum drywall is a complex issue that depends on the interpretation of the NEC and local building codes. It is always best to consult with the local building inspector or authority having jurisdiction before proceeding with this type of installation. It is important to prioritize safety and compliance with all applicable codes and standards when installing electrical wiring. Remember that the NEC is not a design manual, but a set of minimum standards. Good electrical design often exceeds these minimums to provide for future expansion and increase safety margins. Consider using larger conductor sizes than required to reduce voltage drop, especially on long circuit runs. This can improve the performance and efficiency of electrical equipment and reduce the risk of overheating. Another important consideration is grounding. A properly grounded electrical system is essential for safety and to prevent electrical shock. The grounding system provides a low impedance path for fault current to flow back to the source, which causes the overcurrent protection device, such as a circuit breaker or fuse, to trip and energize the circuit. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for connecting grounding conductors to equipment. Surge protection is another important aspect of electrical system design. Surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Surge protective devices, SPDs, are designed to protect electrical equipment from surges by diverting the surge current to ground. SPD should be installed at the service entrance and at any other locations where sensitive electronic equipment is located. Arc fault circuit interrupters, FSIs, are another important safety device that can help to prevent electrical fires. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can occur when insulation on wiring becomes damaged or frayed. When an arc fault is detected, the FSI trips and energizes the circuit, preventing a fire from starting. The NEC requires FSIs in many locations throughout the home, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, GFCIs, are another type of safety device that can help to prevent electrical shock. GFCIs are designed to detect ground faults, which are dangerous electrical conditions that could occur when current leaks from a circuit to ground. When a ground fault is detected, the GFCI trips and energizes the circuit, preventing a person from being shocked. The NEC requires GFCIs in many locations throughout the home, including bathrooms, kitchens, and outdoor areas. Proper labeling of electrical panels and circuits is essential for safety and convenience. The panels should be clearly labeled with the voltage and amperage of the service, the location of the main disconnect, and the circuit numbers. Each circuit breaker or fuse should be labeled with the location of the loads that it serves. This will make it easier to identify and troubleshoot electrical problems in the future. Regular maintenance of electrical systems is important to ensure their continued safety and reliability. This includes inspecting wiring for damage, tightening connections, and testing safety devices such as FSIs and GFCIs. Electrical systems should be inspected by a qualified electrician at least every 3 years. When planning an electrical project, it is important to consider the future needs of the building. This includes providing adequate capacity for future loads, such as new appliances or equipment. It is also important to consider the location of outlets and switches to ensure that they are conveniently located for the occupants of the building. Using energy-efficient lighting and appliances can help to reduce energy consumption and save money on utility bills. LED lighting is a highly energy-efficient option that can last for many years. Energy Star appliances are also designed to save energy and water. When installing electrical wiring, it is important to use the correct size and type of wire for the application. The NEC specifies the minimum wire size for different types of circuits based on the amperage rating of the circuit breaker or fuse. It is also important to use wire that is rated for the temperature and environmental conditions at the installation site. When making electrical connections, it is important to use proper techniques and materials. Connections should be tight and secure to prevent overheating and arcing. Wire connectors should be rated for the size and type of wire being used. When running electrical wiring through walls and ceilings, it is important to protect the wiring from damage. This can be done by using conduit or cable trays. Wiring should also be properly supported to prevent it from sagging or becoming damaged. When working with electrical systems, it is important to be aware of the potential hazards. Electricity can be dangerous, and it is important to take precautions to protect yourself from harm. Always disconnect the power before working on any electrical circuit. Use insulated tools and wear rubber gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electrical safety is paramount. The information provided is for general guidance only. It is essential to consult with qualified professionals and adhere to all applicable codes and regulations for safe and compliant electrical installations. The responsible party should always obtain proper permits and inspections to verify that the electrical system complies with all codes and regulations. The specific requirements for electrical installations can vary depending on the location and the type of building. It is important to check with the local building department to determine the specific requirements for your project. The electrical work should only be performed by qualified individuals who have the necessary training and experience. Improper electrical work can be dangerous and can lead to electrical fires, shocks, and other hazards. If you are not qualified to perform electrical work, hire a qualified electrician to do the work for you. The electrician should be licensed and insured to protect you from liability in case of accidents or damage. Always follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. Failure to follow the manufacturer's instructions can void the warranty and can also lead to safety hazards. When working with electricity, it is important to be aware of the potential hazards of arc flash and arc blast. Arc flash is a dangerous electrical explosion that can occur when a short circuit occurs in the air. Arc blast is the pressure wave that is created by an arc flash. Arc flash and arc blast can cause serious burns, injuries, and even death. To protect yourself from arc flash and arc blast, wear appropriate personal protective equipment (PPE) such as arc-rated clothing, gloves, and face shields. Also, follow safe work practices, such as energizing equipment before working on it and using insulated tools. Consider running a separate neutral conductor for each circuit. This is known as a dedicated neutral, and it can help to reduce voltage drop and improve the performance of electrical equipment. A dedicated neutral can also help to prevent nuisance tripping of ground fault circuit interrupters, GFCIs. When installing electrical wiring in a commercial building, it is important to consider the requirements of the Americans with Disabilities Act, ADA. The ADA requires that electrical outlets and switches be accessible to people with disabilities. This means that they must be located within a certain height range and must be operable with one hand. It is also important to consider the requirements of the National Fire Protection Association, NFPA. The NFPA publishes standards for electrical safety, including NFPA 70, the National Electrical Code, and NFPA 70E, Standard for Electrical Safety in the Workplace. These standards provide detailed requirements for electrical installations and work practices to help prevent electrical fires and injuries. Conduct regular infrared scans of electrical panels to identify hot spots. Infrared scanning can detect areas of excessive heat in electrical panels, which can indicate loose connections, overloaded circuits, or other problems. Early detection of these problems can prevent electrical fires and equipment failures. Use a power quality meter to monitor the electrical system. A power quality meter can measure voltage, current, frequency, and other parameters of the electrical system. This information can be used to identify power quality problems such as voltage sags, voltage swells, and harmonics. Correcting power quality problems can improve the performance and efficiency of electrical equipment. Consider using a smart electrical panel. A smart electrical panel can monitor the electrical system and provide real-time information about energy consumption, circuit status, and other parameters. This information can be used to optimize energy use and improve electrical safety. A smart electrical panel can also be used to remotely control electrical loads, such as lighting and appliances. This can be useful for energy management and for providing convenience.